This is chapter 24, problem number 31. So the power radiated by the sun is 3.9 times 10 to the 26 watts, and the Earth orbits the sun in a nearly circular orbit of radius 1.5 times 10 to the 11 meters. The Earth's radius of rotation is tilted by 27 degrees relative to the plane of the orbit. So, sunlight does not strike the equator perpendicular. What power strikes at 0.75 meters square patch of flat land at the equator at point Q? So, this is the image that was given within the book. So here's the Earth and the equator, and here's point Q and the sunlight coming in, and then this is the axis of rotation, and this is the 27 degrees. Actually, I'm just going to scroll and show you the actual picture. Okay, here it is. So you get the image of the problem. So I started off by listing my givens. So we know that the power is 3.9 times 10 to the 26 watts, which is radiated from the sun. And then we also know that our radius is 1.5 times 10 to the 11 meters. So the axis of rotation is equal to 27 degrees. So they want us to find what power strikes at 0.75 meters squared at point Q. So we know that the formula given for 24.3, we can start with we know that S equals P over 4 pi r squared. So what I have denoted here is that this is the area perpendicular. And the power is equal to S times area perpendicular. So in order to find this area perpendicular, we take our radius, cosine, and the angle in order to find our perpendicular area. And now once we have that, in order to find the power that strikes at point Q, we plug in everything that we have. So P equals SA. If you manipulate this formula right here to here, you'll end up with this. So that's going to end up equaling, since S is equal to P 4 pi r squared, and then the area. So we know that the area, this is the area. So you end up with P over 4 pi r squared times 0.75 meters squared cosine 27 degrees. So we just plug everything in. So for P we have the 3.9 and then over 4 pi and then r and square. Now don't forget to square your radius. So this is just the math work that I went through step by step. And I basically had to sum down the S into one number so that I could eventually calculate it, and that ended up being 1,379.38. And then we multiply that by 0.75 meters squared, and then you multiply that by cosine 27. So our final answer was 921.78 watts. I put here that it rounded to 920 because of the 2 sig figs, but ideally it rounds up to 922 watts. problem's very difficult. You just have to get the formulas that we learned within the chapters and utilize those. Thanks for listening.